Okay, so we're going to talk about the air conditioning system of a car today. In order for somebody to understand how the AC system works on a car, you need to understand that energy cannot be created or destroyed. It can only be transferred. We are trying to take the heat from inside the cabin of the car and dissipate it somewhere else. Because we can't take that heat, which is energy, and destroy it. So the way we do it, we take the energy from inside the cabin, take it outside, and dissipate it outside. How do we do that? We use what's called a refrigerant, a brand name Freon. Some people know it as R134A, R22, R12, 1234YF. Those are different chemical compounds that in the AC system as a refrigerant. The properties of those refrigerants that are similar are they all boil at a very low temperature. Anytime you have something boil, it has to take energy from somewhere in order for it to boil. For example, water boils in a stove. It takes the energy from the stove and the flame to evaporate the water. Refrigerant boils. For example, we're going to talk about R134A a lot because that's the most commonly used refrigerant in the cars today. R134A boils at negative 12 degrees Fahrenheit at atmospheric pressure. We manipulate the boiling point of the refrigerant using pressure. The higher the pressure, the higher the boiling point. That's why pressure cookers are used to cook food faster, because you're able to get the food higher than 212 degrees boiling point of water because you pressurize it, so it reaches higher temperatures. Okay, so anything, when you pressurize it, you increase the boiling point, you reduce the pressure, you put it under a vacuum, it boils even earlier. In an AC system, we use an AC compressor to increase pressure. We're going to draw a little compressor here. I'm just going to draw a box and I'm going to write down C on there, or COMP, compressor. You're going to have a line coming off the compressor, which is going, I'm going to write down H for high side. This is where you have high pressure, okay? Anywhere from 150 to 250 PSI would be our normal pressure. Compressor compresses vapors. So this is your high side vapor line. High side vapor line then goes into what's called the condenser. We're going to draw a condenser. Comes out as high side liquid. Still got the same pressure. Maintains the same pressure, but it comes out as high side liquid. That high side liquid then goes through what's called either an orifice tube, or an expansion valve, which is basically a restriction, okay? After that restriction, we have what's called an evaporator core. Some people also call it the coil. In your house it's called a coil. In the car we call it an evaporator core. From the evaporator core, it goes right back to the compressor, the suction side of the compressor. From the expansion valve to the suction side of the compressor is called the low side. Anywhere from 25 to 45 PSI would be our normal range. The temperature, the ambient temperature, the cabin temperature will change these pressures the higher the temperature, the higher the pressure. So to follow the state of refrigerant, we come out as vapor, high side vapor from the compressor. It condenses inside the condenser, which is opposite of boiling, and it turns into high side liquid. Goes from high side liquid, it sprays, because there's a restriction, slowly sprays into the evaporator core, boiling because there's a lower pressure here because the compressor is sucking here, creating a suction because the compressor is creating suction here. As the refrigerant comes into the evaporator core, it evaporates, taking in energy, goes into the compressor, and compressor compresses it to increase boiling point, and then it dissipates energy in the condenser. Okay, so you got a condenser, evaporator core, compressor, and then lines and hoses, expansion valve or orifice tube. There's another component they put in there called an accumulator or receiver dryer. The purpose of that is to absorb the moisture that's in there in the system. It also holds the PAG oil or the ester oil that is to lubricate the compressor. If you have a leak somewhere in the system, as soon as the refrigerant comes out, it's going to boil out. So you're not going to be able to see where it's leaking from because it's not in a liquid form anymore. It's just going to leak out as vapors. So we also put dye in the oil so it accumulates and we can find the leak under fluorescent light. That's a common way of finding the leak in the system. You have two service ports, one on the high side, one on the low side, somewhere around here. We use those ports to charge the system with refrigerant or evacuate or vacuum the system. Anytime you open the system up, you need to vacuum the system for 45 minutes to get all the moisture out of there, because moisture does not behave like the refrigerant does. If you don't want it in there, it'll corrode everything and it won't work right. Your system will not work efficiently. So this AC system, the flow of refrigerant is in everything from your freezer to your fridge to your house AC to your car AC. All of it works on the same principle. The condenser is the one you have outside your house. Your compressor is actually built into it in your house. The round thing that you got outside your house, they call it the condenser unit. You got a compressor in it. So everything is kind of combined. The cars, we call it evaporator core. In house, you call it a coil. That's inside your house in the air box, you know, in the furnace where the air is blowing. Everything is kind of in the outside unit other than the coil. You also have sensors. You have an ambient temperature sensor. You have an evaporator core temperature sensor, which is mounted on the evaporator core. You also have pressure sensors on the high side to turn the fan on and off, because you know the fan goes on the condenser that blows air across the condenser to keep it cool, to be able to dissipate that energy that you took in on the inside of the cabin. So that fan switch tells the computer or a relay to turn that fan on once the pressure exceeds a certain amount. I've seen on some cars, as soon as you turn the AC on, they'll turn the fan on. I've seen on some cars, it actually only uses the high side pressure switch to turn the fan on and off. Some cars, you will have a pressure switch on the low side, which is to prevent compressor from going bad. Once the pressure drops below a certain pressure, it'll turn the compressor off, because that means you're low on refrigerant, or the condensers, the evaporator core has gotten really cold. That's why the pressure on the low side is dropping, so it'll shut the compressor off. Computer turns the compressor on and off multiple ways. What I mean is there are different AC compressor designs. So the computer can turn the compressor on and off depending on the design of the compressor. You have a magnetic clutch. You have a variable valve, which controls the amount of flow. It basically will put a solenoid between the high side and the low side, and it can open and close that solenoid, reducing the amount of flow because it's bypassing some. The compressor is belt driven on most cars except for electric and hybrid cars. And this is a basic understanding of how our AC system works.